Picture this. It's a quiet summer evening in eastern Ukraine, and a Ukrainian artillery crew is about to pull off one of the most devastating precision strikes of the entire conflict. What started as a routine mission against a Russian ammunition depot would spiral into a deadly game of cat and mouse, where split-second decisions meant the difference between mission success and total annihilation. This is the true story of how 4 Ukrainian-made missiles managed to outsmart an entire network of Russian air defenses and trigger an explosion so massive it could be seen from space. The clock showed 10:30 in the evening on July 2nd when the Ukrainian Vilkha-M crew near Pokrovsk began their final preparations. These weren't just any ordinary soldiers. They were operating Ukraine's most sophisticated indigenous rocket system, a weapon that represented years of careful engineering and national pride. The 12-tube launcher sat loaded with 4 precision-guided missiles, each one a technological marvel weighing 800 kilograms and carrying enough explosive power to punch through reinforced concrete bunkers. But as the crew prepared to unleash their payload against the Russian ammunition depot, something unexpected happened that would transform this routine strike mission into a desperate fight for survival. Their passive detection equipment suddenly lit up like a Christmas tree, revealing the distinctive electromagnetic signature of a Russian Zuber counter-battery radar system operating 38 kilometers away. This was the moment when everything changed. The Ukrainian radar operator's blood ran cold as he recognized the frequency pattern painting his screens. The Zuber system, known to NATO forces as the Zoo Park, represented one of Russia's most capable artillery detection platforms. This sophisticated radar could pinpoint the exact location of enemy artillery within 30 seconds of detecting an outgoing round, and with a detection range of 23 kilometers, the Ukrainian crew had just walked into a deadly trap. Making matters worse, the crew had fired a harassment barrage just 15 minutes earlier, which meant Russian multiple launch rocket system crews were already hunting for them based on their previous position. Standard Russian response protocols indicated they had exactly 6 minutes before BM-30 Smerch rockets would begin raining down on their coordinates with devastating precision. The Ukrainian crew chief faced an impossible choice: abort the mission and retreat to safety, or complete their fire mission while incoming rockets screamed toward their position. The decision came down to pure military mathematics. They had a 12-tube Vilkha-M launcher loaded with 4 missiles, targeting data already uploaded, and just enough time to execute if everything went perfectly. There was no margin for error. What happened next showcased both the incredible technological sophistication of modern Ukrainian weapons systems and the raw courage of the soldiers operating them. Each Vilkha-M missile required precise targeting coordinates loaded through a ruggedized military tablet that communicated with the missile's guidance system via encrypted data links. Under normal circumstances, this process took 3 minutes per missile. The crew had to complete it in 90 seconds, while Russian radar painted their position and enemy rockets flew toward them through the darkness. The Vilkha-M system itself represents a remarkable achievement in Ukrainian military technology. Developed by the Kiev Design Bureau, these missiles incorporate GPS, GLONASS, and inertial navigation systems that combine to provide accuracy within 10 to 30 meters at maximum range. The 170-kilogram warhead packs enough punch to penetrate heavily fortified targets, making it perfect for striking hardened ammunition storage facilities. But uploading targeting coordinates while under active radar surveillance added lethal complexity to an already dangerous process. At 32 minutes past 10, Russian electronic warfare systems intensified their jamming across all GPS frequencies, causing the Ukrainian tablet screen to flicker and lose satellite lock. The gunner was forced to switch to manual input mode, trusting pre-surveyed coordinates without GPS verification. Any error would mean missing the target after revealing their position to every Russian unit within 100 kilometers. As if the situation couldn't get more desperate, thermal sensors detected heat plumes 32 kilometers to the northeast. The Smerch launchers had already fired. With rockets traveling at approximately 1,200 meters per second, the Ukrainian crew had roughly 4 minutes before impact. The mathematical precision required was staggering. They needed to fire all 4 missiles before displacement, with each launch requiring 20 seconds of preparation time and standard doctrine demanding 45-second intervals between launches to prevent thermal damage to the launcher. The first Vilkha-M missile roared from its tube at exactly 34 minutes past 10, its launch signature immediately detected by every radar system within 50 kilometers. The crew didn't wait to observe the trajectory. There simply wasn't time. The gunner was already authorizing the second launch while the driver started the 8x8 transporter's engine, preparing for the desperate escape that would follow. Ukrainian military doctrine demanded displacement within 90 seconds of first launch, but completing the full fire mission took absolute priority. The second missile launched 30 seconds later, its exhaust plume creating a 40-meter thermal column visible to Russian infrared sensors. By this point, the Zoopark radar had calculated their position to within 50 meters and transmitted coordinates to multiple Russian fire units. The crew chief could now hear the distinctive whistle of incoming Smerch rockets, a sound that meant 30 seconds to impact. The third missile launched at 35 minutes past 10, its blast overpressure shattering windows in abandoned buildings 200 meters away. The launcher's thermal coating was already showing stress fractures from the rapid-fire sequence, but they needed one more shot before they could escape. 30 seconds later, the fourth and final Vilkha-M missile launched just as the first Smerch rocket impacted 400 meters north of their position. The explosion sent deadly shrapnel overhead as the 30-ton vehicle lurched forward, accelerating away while Russian rockets bracketed their former position. They had revealed themselves to every enemy unit within 100 kilometers, but 4 precision missiles were now streaking toward their target at 1,100 meters per second. The real test, however, was just beginning. At 40 minutes past 10, the lead Vilkha-M rocket descended through 8,000 meters altitude as it approached the forward edge of Russian air defenses. The missile's onboard computer processed navigation updates 50 times per second, while analyzing jamming signals, attempting to corrupt its GPS receivers. In about 60 seconds, it would either deliver its warhead successfully or become another casualty in the electronic warfare battle raging over the Donbass region. The missile's triple redundant guidance system immediately detected degraded GPS signals as it crossed into Russian-controlled airspace. Signal-to-noise ratios dropped below acceptable thresholds, forcing the guidance computer to switch to GLONASS backup systems. But in a cruel irony, Russian forces were jamming their own navigation system too, creating an electromagnetic dead zone specifically designed to defeat precision weapons. Within 500 milliseconds, the Vilkha-M defaulted to pure inertial navigation, its fiber-optic gyroscopes maintaining course accuracy of 0.2 of a degree per hour. This was where Ukrainian engineering excellence would either triumph or fail against one of the world's most sophisticated air defense networks. 28 kilometers ahead, a Tor M2 air defense systems combat vehicle detected the incoming rocket on its surveillance radar. The system operator watched his scope as the target descended through 6,000 meters at 1,100 meters per second, well within engagement parameters. The Tor's fire control radar began tracking, its phased array antenna focusing 600 kilowatts of power on the Vilkha-M's radar cross-section. The Tor M2 represents Russia's most capable point defense system against precision munitions. Its missiles can engage targets from 1 kilometer to 15 kilometers range at altitudes between 10 meters and 10,000 meters. The system's reaction time from detection to launch is just 5 to 7 seconds, with missiles accelerating to nearly 3 times the speed of sound within 2 seconds of leaving their vertical launch tubes. Against a ballistic target following a predictable path, it should have been a guaranteed interception. But the Vilkha-M wasn't flying predictably. At 42 minutes past 10, its guidance system initiated a programmed maneuver, banking 15 degrees left while maintaining descent angle. This minor course correction moved it outside the Tor's pre-calculated intercept zone, forcing the fire control computer to generate a completely new solution. The Russian operator authorized automatic engagement anyway, and 2 interceptor missiles erupted from their launch tubes 30 seconds later. But the Vilkha-M's designers had studied Russian air defense tactics extensively. At 42 minutes past 10, the rocket performed another pre-programmed jink, this time 20 degrees right with a slight pitch adjustment. The maneuver added only 300 meters to its flight path, but completely invalidated the Tor's firing solution. Realizing the first missiles would miss, the Tor operator switched to manual tracking mode. His screen showed the target now at 3,000 meters altitude, 18 kilometers downrange, with impact in less than 60 seconds. He fired 2 more missiles while alerting adjacent air defense units. A Panzer S-1 system 12 kilometers east acknowledged and began searching its sector. The second pair of Tor missiles performed better, their proximity fuses detonating within 50 meters of the Vilkha-M. Shrapnel peppered the rocket's aluminum skin, but failed to penetrate the warhead casing or damage critical guidance components. The near miss did affect trajectory slightly. Onboard accelerometers detected a 2-degree deviation, which the flight computer immediately corrected. As the lead missile descended through 1,500 meters, the second Vilkha-M entered the engagement zone 30 seconds behind. The Tor crew, focused on the lead target, didn't detect it until 43 minutes past 10. They had 4 missiles remaining and 2 targets approaching. Standard doctrine prioritized the closest threat, but engaging multiple high-speed targets simultaneously exceeded the system's real-world capabilities. The Panzer S-1 system tried to help, but faced its own problems. The Vilkha-M missiles were approaching from just outside their optimal engagement angle, requiring the turret to traverse 140 degrees while calculating firing solutions. By the time its missiles were ready, the lead rocket had descended below 500 meters, entering the terrain masking zone that made terminal interception nearly impossible. At 49 minutes past 10 local time, the lead Vilkha-M rocket entered its terminal phase 8 kilometers from the ammunition depot. 4 separate Russian air defense systems converged their sensors on the incoming threat, creating overlapping fields of radar energy that painted it like a beacon. The next 45 seconds would determine whether months of Ukrainian intelligence work would pay off or vanish in a failed interception. The Tor M2 crew had one chance left. Radar indicated the missile was following terrain at 400 meters altitude, using a small ridgeline to mask its approach. In 15 seconds, it would clear the ridge and dive toward the target. The operator preset his remaining missiles for the calculated pop-up point and waited with finger hovering over the firing button. 3 kilometers south, a Panzer S-1 finally joined the engagement. This modern system carried 12 missiles with radio command guidance, effective out to 20 kilometers. The crew had been tracking the Vilkha-M since it descended below 1,000 meters, but couldn't achieve solid lock through the ground clutter. Their phased array radar cycled through different frequencies, trying to burn through interference patterns created by the complex electromagnetic environment. The depot's last line of defense was a ZSU 23-4 Shilka positioned on the facility's northern perimeter. Its 4 23mm autocannons could pump out 3,400 rounds per minute, creating a wall of lead designed to shred low-flying aircraft and missiles. The gunner traversed his turret toward the anticipated approach vector, his radar-guided fire control system struggling to differentiate the incoming missile from background returns. At 300 meters per second closure rate, he'd have perhaps 3 seconds to engage once the target became visible. Everything now depended on split-second timing and the deadly mathematics of modern warfare. At 49 minutes past 10, the Vilkha-M crested the ridge exactly where the Tor operator predicted. Both remaining interceptor missiles launched instantly, their rocket motors illuminating the darkness as they accelerated toward the intercept point. The missile's altitude was now 380 meters and dropping, following a ballistic trajectory that would impact the depot in 12 seconds. But the second Vilkha-M chose that moment to appear, cresting the same ridge 2 kilometers north. The Pantsir crew, startled by the new threat, split their engagement between targets, firing 3 missiles at each instead of concentrating fire. This violated doctrine requiring concentrated firepower, but panic had overridden training. The lead Vilkha-M's warhead was now armed as it passed through 200 meters altitude. Impact fusing circuits activated, while the radar altimeter provided final height corrections. Below, Russian ammunition handlers scrambled for cover, abandoning forklifts loaded with Grad rockets. They'd been alerted 30 seconds earlier, but moving thousands of tons of ordnance required hours, not minutes. At 50 minutes past 10, the Tor missiles passed within 30 meters of the lead Vilkha-M, close enough for proximity fusing, but the target's speed and angle exceeded parameters. Both interceptors detonated harmlessly behind the rocket as it entered its terminal dive. The Shilka opened fire at 600 meters range, its quadruple cannons filling the air with tracer rounds. The gunner held the trigger for 2.5 seconds, expending 280 rounds in a futile attempt to create an impenetrable barrier. The third Vilkha-M appeared 20 seconds later, approaching from the east where air defense coverage was thinnest. Across the depot, sirens wailed as personnel ran for bunkers that wouldn't save them from what was coming next. At 49 minutes and 10 seconds past 10, the lead missile's radar proximity fuse detected the warehouse roof 5 meters below. The warhead detonated on contact, 170 kilograms of high explosive, creating an overpressure wave that collapsed the building's eastern wall instantly. But this was just the primer. Inside were thousands of tons of Russian ammunition, about to begin the deadliest fireworks show in the Donbass region. The initial explosion reached the nearest ammunition stack, pallets of 152mm artillery shells stacked 4 meters high. The blast wave compressed air between wooden crates, creating temperatures exceeding 3,000 degrees Celsius. Within 300 milliseconds, the first secondary explosion erupted. The second Vilkha-M impacted the northern storage building 30 seconds later, its warhead penetrating the reinforced roof before detonating among crates of BM-21 Grad rockets. Each rocket contained over 18 kilograms of solid fuel that burned steadily when ignited properly or exploded violently when subjected to shock detonation. The initial blast set off 6 rockets simultaneously, their combined explosion lifting the 15-ton roof structure completely off its supports. The third Vilkha-M struck the western warehouse at 50 minutes and 20 seconds past 10, targeting pallets of advanced Grad rockets equipped with submunition dispensers designed to scatter anti-personnel mines. The heat and overpressure caused the submunitions to detonate inside their casings, creating a devastating secondary blast that collapsed the building's structural supports. Burning rocket fuel sprayed across the compound like napalm, creating an inferno that would burn for hours. At 51 minutes past 10, the fires reached the depot's prize stockpile, S-300 surface-to-air missiles in storage configuration. Each missile contained 133 kilograms of high explosive plus solid rocket fuel in its sustainer motor. The blast wave shattered windows in the city center 3 kilometers away. The fourth and final Vilkha-M arrived at 52 minutes past 10, but its target no longer existed in any meaningful sense. Programmed for the Eastern Warehouse, it instead impacted a burning hellscape of twisted metal and exploding ordnance. Its warhead added to the conflagration, but by now the chain reaction had become self-sustaining. Solid rocket motors launched themselves horizontally, spinning wildly before detonating against perimeter fencing or other buildings. Russian firefighting teams 2 kilometers away could only watch helplessly as temperatures exceeded 1800 degrees Celsius. At 55 minutes past 10, an underground bunker containing 300mm Smerch rockets detonated, creating a 40-meter crater and distinctive mushroom cloud that social media captured from multiple angles. By 10 minutes past 11, 4 massive fires glowed where warehouses once stood. Conservative estimates place the damage at 3,000 tons of ammunition destroyed, representing 3 weeks of Russian artillery capability suddenly vaporized within hours. Panicked orders dispersed remaining stockpiles across multiple facilities, reducing efficiency and increasing vulnerabilities, exactly as Ukrainian planners intended. This remarkable strike demonstrated how precision weapons, courage under fire, and superior tactics could overcome even the most sophisticated air defense networks. The Ukrainian crew's willingness to complete their mission under desperate circumstances, combined with the engineering excellence of the Vilkha-M system, achieved strategic results far beyond the tactical scope of a single strike mission. The reverberations of this night would echo through Russian supply chains for months, forcing fundamental changes in ammunition storage and distribution that degraded artillery effectiveness across the entire front line. Sometimes, 4 missiles launched at exactly the right moment can change the course of a war.